Again, want to welcome everyone. I'm Diana Robinson. I work in the office, UAS Office of Integration. And my focus is on, sorry, it's coming up, is on outreach and engagement. I have the pleasure to work with some really great people within the AUS, and we say AUS because in FAA, many of our groups begin with aviation, so aviation and then unmanned systems. So we are all working together to try to make your operations happen. Some, will be happening. They're maybe not quite there yet. But we are just really delighted today to have Lance Brady with us. And we also have Chris Couture with us. Chris is with the FAA, and he was going to tell you a little bit about what we're doing internally as far as how we work and how we're using UAS in the environment and things that we're looking at. I don't have, my notes are not coming up. So we're just going to go ahead and begin. Lance, if you don't mind, to go ahead and pull up your slides. Lance I met back in the summer. He actually, with two others, we were on a panel for, and it's called an environmental forum. Our division or group here was AEE, which is our environmental office. And they put together this, it was an internal meeting. And so all three of the presenters were fabulous. I've asked Lance to join us today to share about what's happening within USGS, the Geological Survey, US Geological Survey. I'm getting tongue-tied here. Lance, your bio is not even popping up, so please tell the group a little bit about yourself. I know he's worked with the Department of Interior. He's got a really impressive background, and I know that you are going to enjoy everything that Lance has to say today.
All right, is my screen being shared?
It is being shared, and something that maybe would have even helped me is I should have asked everyone maybe to turn off their cameras. Sometimes that kind of slows down the system. When we have questions after each of the presentations and at the very end, you are welcome to turn them back on. We'll close up the presentation. But for now, if you turn off your camera, that may help. I'm gonna turn off mine as well. Lance, thanks again for being here.
All right, excellent. Well, thank you for inviting me to present to this group. It's pretty exciting to share my experiences and also my passion for not only aviation, but for mapping. And I can talk a little bit about that. I grew up in southeastern Arizona. I started flying real aircraft when I was about 14, 15 years old. I was a line serviceman at a local airport there and spent some time around aircraft at a pretty young age. From there, I transitioned out of high school into an aviation program at Cochise College, small college in southeastern Arizona, where I really wanted to become a professional pilot, but my pocketbook was not that big, so I decided to take the mechanic route and went through their A&P school there. Decided that I also wanted to maybe do something else, and so while I was turning wrench and working on aircraft, I went back to my back home and started looking at getting another degree where I got an associate's degree in anthropology. I always kind of had a passion for the outdoors and not really sure of the link between aviation and anthropology, but there it is. So I soon got married and moved to Phoenix, where I worked at Phoenix Sky Harbor Airport for a little company called Sawyer Aviation, where we were a Cessna service center. And decided at that time we had a small baby and my wife and wasn't really making a lot of money and thought maybe I needed more schooling. And I happened to be working for a company, actually for turning wrench on an aircraft that the company did aerial photography work. And I really got really interested in aerial photography and what that was about and kind of remote sensing. So I went to school at Northern Arizona University, where I got a degree in geography with a minor in remote sensing. So spent several years in private industry, engineering firms, specifically working, doing photogrammetry and remote sensing work. And then took a job with the federal government, with the United States Bureau of Land Management within the Department of Interior. and spent nearly 20 years with the Department of Interior. In about the late, actually early 2000s, when I came on with the federal government, was about the time that we started exploring some utility use of unmanned aircraft. And from there, I kind of jump into what I do now and how I got to where I'm at with working with the environment and the tool being the unmanned aircraft. And so my name is Lance Brady. I do work for the National UAS Project Office. I am the chief of that office under the United States Geological Survey, under the Department of Interior. And so we have been in existence for some time, since about 2008, but really who the USGS is and what our mission is, we're really the science arm of the Department of Interior. There's a lot of sub-bureaus of the Department of Interior, to include the Bureau of Land Management, the National Park Service, U.S. Fish and Wildlife Service, Bureau of Ocean Energy Management. And so we're really the science arm. And we look at not only the biological resources, but the hydrologic resources, energy development, mineral, both hard rock and fluid minerals research within the department. And our group specifically is in the National Land Imaging Program. And that is we have systems such as Landsat satellite that we manage for the nation, but we also have other assets that we use to do topographic mapping and our 3-depth program. And so that's kind of who we are. The Department of Interior is pretty interesting, along with other bureaus like the U.S. Forest Service and Corps of Engineers and DoD lands, account for nearly 1/5 of all acreage within the United States. So we have a pretty big mission. There's lots that we need to do in terms of monitoring those lands for future generations. And as you can see on the right side of this screen here, kind of this really where the niche for small UAS fits. And you can take Global Hawk and you can put in other manned aircraft into those type of altitudes, remote sensing platforms. Obviously, we have the satellite imagery, but really this niche is the 1,200 foot and below. And it really has opened up an opportunity for the federal government and the Department of Interior to get information that we were unable to get just 15 years ago. So it's really opened up kind of a little niche market for environmental monitoring within the USGS and within the department. Our current suite of aircraft, this is what we currently fly. We're on our 3rd generation of systems within USGS and the Department of Interior. We are in the process of evaluating new systems for kind of our 4th generation aircraft, but these are the current systems we're currently operating. And the USGS UAS Project Office really was created in 2008, even though that we were exploring the technology well before that. In 2004, we flew a Silver Fox UAS. They were based out of Tucson over Mount St. Helens during some grumblings that Mount St. Helens was going through in about 2004. And then we did some exploration with NASA and with the U.S. Forest Service on some UAS development in the early 2000s as well. Our first systems we acquired were actually from the military. We acquired the RQ-11 Ravens, which you see up there in the upper right. Those were being disposed of by Redstone Arsenal down in Huntsville, Alabama. And so we were able to acquire several of these systems to kind of run through a test and evaluation on how we could use the UAS technology within the USGS. Our first training happened shortly thereafter. We trained with the military in those systems down at Fort Bliss and at Dugway Proving Ground in Utah. And then our first operations in the national airspace happened in 2011. Some more recent news in 2019, due to an executive order and also a secretarial order, our UAS operations ceased except for emergency response missions and preparing for emergency response missions. That sounds pretty drastic, which it was at the time. However, we have found ways to operate where we were practicing or using our sensors for future emergencies and for characterization of land hazards. And USGS fits very well into that, since a lot of our mission is characterization of those land hazards, whether it be volcanoes, whether it be high hydrologic flows, geologic hazards, landslides, things like that. And so we do still conduct missions. We are hoping that the grounding order that ceased our missions for other projects will hopefully be lifted here pretty quickly, and we can get back to normal operations. So a little bit about our training program within the department. Not only is there, the FAA policies that we abide by, Part 107 certification, but we also have our own internal training program, what we call the A450 Basic Small UAS course. That course is given across the United States and our territories, and we put to this point, we've put nearly 400 UAS pilots through that within the department. And specific to USGS, we've put about 150 students through that training. We also have to maintain currency on our aircraft, so we need to fly those aircraft every 90 days, our 3 takeoff and landings by policy. And then we also, every 2 years, need to fly with an instructor pilot to show that we are proficient in flying the airframes that we're qualified to do. We're all issued a pilot card. So we all have Part 107 cards, but we also have DOI pilot cards, and those pilot cards kind of lay out what airframes that we can pilot, what operations we can conduct, whether it's operations within temporary flight restrictions areas, whether we can operate at night, whether we can operate beyond visual line of sight, and whether we can operate extended line of sight operations. We also conduct other training outside of just UAS specific training. We have advanced operator courses that we get into more complex missions, but we also have some data processing courses, things like photogrammetric training, Lidar training, some of these advanced processing courses that we put on. Since COVID, we've gone away from in-person training for these advanced courses, and we are now using, a virtual environment. So we're actually able to push a lot of students through. Our last photogrammetry class in and of itself, we had 50 participants, and we have an upcoming training here at the end of this month, and we have about 45 that will go through the training. So we are able to actually get a lot more information out there using the virtual method. Once things open back up, we'll probably do a combination of virtual and in-person training for our advanced courses. So a little bit of the derived geospatial products that we deliver through our systems, anywhere from just what we call RGB photos, just regular photos. We don't do too much video missions. We do have a couple, but we really are in the derived products from these systems that we can generate. And so we can develop things with our multispectral cameras, such as NDVI, which really gets into the health of the vegetation that we're looking at. This is an analysis that the agricultural industry uses quite often, but we also use it for forest health and for conducting other missions. Our big one is point cloud generation. So these are elevation, X, Y, and Z data that we colorize. And so we kind of get a rendered 3D perspective of these areas, and those are 3D point clouds. We developed elevation information, and from there we can do cross sections of certain areas, whether it's a stream channel, whether it's a as-built structure of some sort. We can develop these elevation and cross sections. We can also use machine learning and some software that's available called Feature Analyst to actually do feature extraction. So what you see under that feature extraction is in Joshua Tree National Park. So each of those red dots are an individual Joshua tree. And so we're able to use the software to train at what pixels to look at and the characterization of the pixels. And we can pull features, and the computer goes out and finds these areas that look similar to our trained areas to actually pull out features in a data set. We can also classify the point cloud, whether it's ground elevation information, whether it's vegetation, whether it's water, whether it's structure of some sort. We can actually characterize those point clouds. And then 3D modeling, orthophotos, and we can also do volumetric measurements since we are producing these 3D data sets. We'll get into a little bit of the projects that we've been working on. This is just a quick example of things that we've been involved in over the years, and we'll probably get into more specifics later on in the presentation. So not only are we approving aircraft, but each of our sensors that we deploy, we have a division within the Department of Interior called the Office of Aviation Services. And the Office of Aviation Services is really our fleet managers. So they manage our policies and our aircraft, not only in the unmanned world, but also in the manned aircraft world. And for each instrument that we're putting on an aircraft, whether it's manned or unmanned, has to be approved. And so our office is kind of the designated office to do the testing and making sure that these sensors are able to be carried on these aircraft. We send that documentation over to the Office of Aviation Services, who then approves these for mass distribution across all of Department of Interior aircraft. So these are just a smattering of different sensors that have been approved through that process, from basic video cameras to digital SLR cameras to multispectral and hyperspectral cameras to Lidar units. And we have just a whole spreadsheet full of these approvals of different sensors that we can operate. And advanced sensors that we're currently testing right now include some gas sensing sensors, some ground penetrating radar units, some additional Lidar sensors, a larger, what they call a medium format metric camera, like Phase 1 and Hasselblad cameras. We're also working on integration of several hyperspectral units and geomagnetometers, and also telemetry. So these telemetry are just radio receivers. So wildlife may have transmission tags, radio tags that are on them, whether it be collared elk or certain bird species. They may have these radio telemetry tags on. And so we were able to integrate a receiver to this and successfully operated that system. So we've also done some telemetry work. So getting into a little bit on the sensor side, this was in 2018 during the Kilauea eruption, where we installed some gas sensing equipment on a DJI M600, which you see here. This was an ad hoc project. It was not planned. But we were able to work in integration pretty quick to get this sensor deployed in a pretty speedy method. Pretty challenging to do that in an austere environment, but and the unknowns that go around, working in the volcanic environment, from the pretty caustic gases that are coming off, and it's kind of interesting to look at some of our aircraft a couple years later and see some of the corrosion that has happened from some of the caustic gas emissions off of a volcano. So that's one utility. We've also done some integration on the ground penetrating radar. This was a joint project with Juniper Unmanned and Mala, who makes the GPR system. This was used to actually use a radar unit like this to map essentially a stream bottom. So it was actually designed to penetrate water. So we were looking at characterization of the stream banks and the side banks of that stream as well. This is one of our many Lidar units that we operate. And so since about 2019 actually going back to 2019, we started integrating Lidar units, put them in full production in 2020 and in 2021. We get pretty high quality dense point clouds using this. We also are flying a photogrammetric mission at the same time. So we're able to take those laser beam data that comes off, which is basically just XYZ information, so horizontal and vertical information. And then we can tie it to colorization of that point cloud with information that comes off of our RGB cameras. So we pretty much mux the two data sets together so we get a colorized point cloud. And so we do a lot of work with Lidar, and we don't like to be known as kind of production mapping world. We're more research, but due to the expense of Lidar, we kind of migrate more into that production work with our Lidar unit. We've also explored the use of what's called green Lidar. This is a Lidar channel that can be used to penetrate water to a certain depth. We believe the technology has a little bit more to go in terms of these green Lidar units that can be mounted on a UAS due to the weight. So this is really for test and evaluation and experimental test data set, but it can penetrate water to, just shy of a meter. Some of the newer units that have a little bit more power can penetrate more. It's just we don't have an aircraft capable of lifting that payload. So other sensors we're integrating is hyperspectral. We're just recently have installed this Headwall Nano Hyperspec. It's actually an older unit. We had one installed on our larger single rotor helicopter system. And we were on the first mission, and that aircraft had a motor failure, and the aircraft ended up in the Colorado River. We were able to bring the aircraft, get the aircraft back, destroyed the sensor. Took us many years to get the sensor replaced, and so we're now flying that hyperspectral sensor on our M600 platform. We have been flying for close to a year our Resonon Pica. It's actually a Pica L, not an XC2. And we have flown numerous missions this year, including detection of algal bloom or algal bloom detection missions, and also biofilm detection in some of our areas within around San Francisco and the Bay Area in some of the mud flats there. This is an example of the Pica L from our mission in California doing the biofilm. So we not only had instrumentation on the aircraft, but we had a lot of ground research happening with our researchers from spectrometers that were installed along that area that we could use as calibration for the Resonon hyperspectral unit mounted on the M600. We're still learning a lot about it. Once you get into hyperspectral, it's kind of a niche market. And even with a remote sensing background, you really have to be a researcher that understands the specific wavelengths that you're looking at within the electromagnetic spectrum, and whatever you're looking at reflects at a certain band level. And so with not being the researchers per se, the biofilm researchers, we're just there to be the pickup truck for their sensor. And so we deliver the data to them, and they do all their fancy modeling from the information we're providing them. We've also working with Juniper Unmanned and a vendor specific to this geometrics mag arrow demonstrated flight operations to detect basically well casings underground. Pretty successful. We don't own this sensor, but we are working with several vendors on this project. We have demonstrated this. I can't say that this is something that we are going to go full bore at in terms of our research here at NUPO, but it is something that we have tested. This is kind of a very interesting system. This is called QCam. It was developed by a researcher out of Austria along with USGS personnel at some of our river gauge stations. So they mount Doppler radar systems on bridges and on fixed towers to monitor stream flow velocities. We had an idea about taking the same technology and taking it off of a bridge or a structure and putting it up in the air. They're pretty small, low power consumption. And so this system was developed to fly on a 3DR Solo, which is actually a pretty small UAS. And there's a bunch of research around this. We're also working with some partners down in Australia who are also taking the work that we did and expanding it down into Australia. And so this is used to look at river discharge measurements. So it'll put a beam, radar beam down, and through the Doppler technique, be able to calculate velocity of stream flow. We have another method that we use for doing stream flow calculations that have been derived using UAS, and that's what's called LSPIV. So the large scale image velocimetry measurements. And these are using pretty stable UAS with a video camera and is able to calculate velocity and trajectory information based on material that's floating in the water. And so during high flow events, whether it's post hurricane or heavy rainfall events, we have deployed the LSPIV system as well to do stream flow measurements. Also within our water program, we also are tasked with developing models of snow water equivalents. So how much water is contained within snowpack. And so this is a software defined radar. It's essentially a ground penetrating radar unit that's used to, we do either a photogrammetric collect or we do a Lidar collect. And then we use this information. So that'll give us, if we do a pre-photogrammetric collect before the snowfall, and then we do a photogrammetric or a Lidar collect after a snow event or throughout the season, we can calculate the snow depth. But to calculate water, you also need snow density. And so this radar unit, this ground penetrating radar unit, will actually model the snow density. And so if we have density and the depth, we can come to an evaluation of how much water equivalent is within that snowpack. And this helps us for any type of forecasting, whether it be future water that's available within certain watersheds, or if we have a rain on snow event and we're looking at discharge rates, potential discharge rates coming off of a snowpack. This is used in some of that research. There again, we've flown this multiple years up in the Rockies near Winter Park, Colorado, and this is just some examples where we're flying. On the left, a Lidar unit, and then on the right, you'll see all the systems that we're flying, from a RGB photogrammetric platform to the GPR platform, and then the Lidar platform. We can also install sensors, not only gas sensors, but particle samplers. And so this is a project we're working with EPA on their Calabri sensor. And so this is a particle sampling device that's used to fly through like smoke plumes or any other type of gaseous plumes that's coming up, to actually record the particles coming out of that plume. And so we've flown multiple projects. This example here is in 2018. We also flew last year in Kansas, and then just a couple weeks ago in Kansas as well. Next year, we're looking at flying a very similar payload up in Alaska at Poker Flats, doing some research on some smoke plumes there based on oil burning, oil and gas burning. We actually first started out doing some biological applications. Our first mission in the national airspace was mapping the habitat and actual birds, the sandhill cranes down in Monte Vista. But this is a pelican survey, and using those same techniques that we used for defining the Joshua trees, these automated counts or machine learning. We use the same techniques to actually do bird counts. And through these bird counts, we can actually discriminate between the different bird species. So I can't read it here specifically, but there's some, I believe, some terns and some pelicans that are on this island. And we can actually do these automated counts. We're talking thousands of birds here where we can do these counts. And I have another example from Palmyra Atoll on this as well, which is this next slide. So this is Joe Adams, who works in our office, and we have to become pretty creative in how we launch and recover aircraft. This is in a coral reef area around Palmyra Atoll in the middle of the Pacific. And so Joe is installing a multispectral MicaSense camera onto this unit. And from there, flew a lot of the Palmyra Atoll islands, and they were out there for 2 weeks, so there was a bunch of different missions. They were also looking at coconut palms. Coconut palms on this island is an invasive species. It's not something that is natural to the environment. So they were mapping using a hyperspectral camera these coconut palms. They have since gone in and done remediation to remove some of the coconut palms. But using the same imagery with an RGB camera, we can also detect wildlife. And so these are the little blue dots there are individual birds that are occupying those dead spaces in between the trees there and kind of the brush. And so we're also able to detect these wildlife species using essentially the same imagery. Going back to kind of our initial missions that we did with photogrammetric applications, this is an example at Stinking Gulch, where researchers were looking at some of these deposits for fossil indications. And so if you know the elevation that you're looking at within the stratigraphy of the geologic layers, you can pinpoint additional areas where you could potentially have some fossil finds. And so this is what this project was. We also developed cross sections, which are those red lines across that digital elevation model you see there. Another example, this is a contracting. So we also contract some work when we get into more production mode and repeat missions. We try to utilize contractors the best we can. This was an interesting project where we were approached about the proponent actually releasing water out of this dam to do some dam repairs. And so we had a great opportunity when the water was released to actually go in and image what was essentially underwater several weeks prior. And so we used a contractor here to actually fly this and develop not only digital elevation model, but an orthophoto and all the different derivative products that come out of that. So we do use contracting on occasion to get some of this data. This project here, we just completed this past summer. In 2020, the East Troublesome Fire burned a lot of the area around Winter Park into Granby, Colorado, and came over into the Rocky Mountain National Park. And so using a bunch of different sensors from our 10-band multispectral sensor to our Lidar sensor to just RGB cameras, we were able to actually map some of these areas and look at the different fire severity from in different stages of this fire. And so as you can see on the left where we kind of had a scattered burn scar, to the right where it was pretty well nuked from a high intensity burn. And there's indications from how much litter is still on the ground to how much branches and leaves and pine needles occur on the actual residual tree, burned trees, and to actually calculate, and also looking at soil indicators for burn severity. And so, research is still ongoing here. We're planning another flight. Technically, it's not a traditional unmanned aircraft. This next week, we're working with a company. This was actually a mission that our office flew, but we actually contracted with a company called Urban Sky, who has a stratospheric balloon. It's a micro balloon that's able to acquire, I believe, 8-centimeter imagery over this site. And so they're hoping to launch on Monday, if we get good weather, to image this site from a stratospheric balloon as well. Technically, it's unmanned, but it really doesn't fit in the same niche as what we usually work with. Probably our highlight is really our Kilauea response in 2018. We spent almost 5 months at Kilauea, almost 24 hours a day. We not only used USGS pilots, but we brought in pilots from other DOI agencies to help us in this effort. And this was a collaboration during the active eruption of all kind of different technology, whether it be ortho photography production from RGB cameras to gas sensing to water sampling, you name it, it flew. And we it was a pretty interesting project. all flown under a temporary flight restriction. However, the federal government was not the controlling agency of the TFR. It was a local response that was happening with the county of Hawaii. And there was a lot of coordination that needed to happen during this event. We also were able to image certain areas that were becoming inundated with lava, where we could prep certain communities for evacuations based on the intel coming off of the UAS. One very interesting thing, I actually was not out there, but one of the NUPO employees, we actually had an aircraft airborne that was doing a photogrammetric collect over the entire crater. And during the collect, when the aircraft was coming home to land, they received a very, very large earthquake that actually had significant changes to the caldera and to the rim of the crater during that earthquake. When it happened, our employees that were on site, they had equipment that was falling out of vehicles, and people that were standing that were falling down because of the strength of the earthquake and the shallowness of the earthquake. The interesting thing is the aircraft landed, they were able to put a new battery in the camera, put a new battery on the aircraft, fly again. So we literally had a before and after digital elevation model post-earthquake, which you don't really get that opportunity very often to do that. So that was just one kind of interesting thing that happened during that event. This is just some still pictures, and if we have enough time at the end of this presentation, we have some video as well of the Kilauea volcano response. We also, kind of one of these ad hoc projects that came up during Kilauea eruption is down at the bottom of the crater. There was also an area that had water infiltration. And so, USGS scientists wanted to be able to sample that water. So this hydrosleeve was developed that was carried under an M600 and was flown down to the bottom of the crater, which was about 1,200 feet below the top of the rim. And so you can see barely the M600 there with a line and the hydrosleeve at the bottom of that line. And the pilots flew down to the bottom of the crater, were able to sample the water, bring it back up, and the scientists were able to do their chemistry evaluations on the pretty nasty water that was down at the bottom of the crater. So that's really my quick and dirty presentation, trying to come in right around a half an hour. That's my team here at the USGS National Unmanned Aircraft Systems Project Office. If you're interested in our current projects and the current research that we're doing, probably best to look at our Twitter site. We post 3, I guess it'd be Twitter feeds or posts a week. So we try to tie in not only the UAS projects that we're doing, but also generally to the USGS and the research that we're conducting with either UAS or remote sensing. So that's a pretty good site to look at. We also have a website. However, that website can get a little static from time to time. And from there, I can take some questions, and I can start this video here. And let me see if there's a way to turn off the audio. Can you hear the audio,
Yes.
Diana? Okay, maybe I'll just leave it running for a second.
Kind of choppy, but I hear it.
Do you hear the audio from the video?
It's coming and going.
Kind of muted. I can figure that out. All right.
Wow, what a cool, or I should say hot, cool video. Volcano. Thank you so much, Lance. We have 2-3 questions. I want to start off though with just asking, a lot of attendees today are in academia. They're university professors, instructors, and we're always, curious as to skill sets, like what you're looking for when you hire. And I want to tie in with that question. The training that you mentioned earlier, that you were showing earlier, is that like just internally, or is it open to others, or where can they get that training?
Yeah, so the A450 course is really just for Department of Interior employees. However, the curriculum around A450 has been shared with universities, with other government agencies, with the FAA years ago when we were getting our training curriculum approved. This was prior to Part 107. So that information is available and is shareable, but the actual training itself is specific for Department of Interior pilots. If we're using a contractor for an aircraft services contract, like for wildfire, there are some pilots that have gone through that training because there's not really anything comparable to that training out there for some of our contractors. So if we're under flight services contract is our terminology, they either have to demonstrate their capability and their training plan, or we need to put them through our training. So there's been some rare occasions where that's happened, but for the most part, it's Department of Interior. On the data processing side, we open that to everybody. So if we get an email from someone and we have an upcoming class, we'll add them to the list. If we have seats, we'll allow them in there. And if you're a government agency, whether it's a local government agency or a university, we have a lot of those attendees that attend that training. Yeah, so that's that. And then in terms of background, I'm very unique. There's very few of us that actually come from an aviation background. At least in the USGS, most of our pilots are researchers of some sort. So they could have expertise either as volcanologists or hydrologists or biologists, and they're using really UAS is a tool. So it's really their tool, like GIS or some of this other software. It's really their tool to support their research. And in some of the other agencies, they're coming from similar, natural resource backgrounds. Wildfire program is coming with wildfire background, and then they're using UAS as the tool. There's only very few of us that actually have an aviation background that are engaged in this. And this goes, up to 400 plus pilots within the Department of Interior. Very few come from professional aviation background.
Thank you. Another question, Wing Chung, who actually is one of our instructors, professors over at Palomar College, is asking about, can they download the before and after, and I can't say the name, Kilauea? What was the name of the event?
Oh, Kilauea?
Kilauea, thank you. The DIM software.
The software we use for developing the information, or the before and after actually looking at the digital elevation model, like what I have the example of the DM. Is that the question? Digital elevation model?
I assume the latter.
Yeah, so there's some data that's posted to our USGS AROS data center. If you research AROS data center, there is a website that you can download not only unmanned aircraft information or imagery, but also satellite imagery and aerial photography. And some of that data is posted there. We can look at trying to get that data to you if you're interested in it for research purposes.
Awesome. Another question, what's the highest resolution camera that you've used via drone for photogrammetry, and how did the results work out?
Yeah, so that's kind of an interesting question. It really depends on the sensor, the camera you're using, and the altitude you're flying. So there are some missions where we're flying 50 feet above the ground. For some of our paleontological missions, like mapping of dinosaur tracks and Pleistocene tracks like mammoth tracks, we're getting in the millimeter pixel resolution on some of that, but we're flying at 50 feet. We have a project coming up this year that we're scheduled to fly the Statue of Liberty, to do an as-built of Statue of Liberty. There hasn't been a full as-built of it from an outside perspective ever. They've done some ground-based stuff and inside. And so that we're planning on using the 100 megapixel phase 1 metric camera with probably a standout distance of about 50 feet. And we're looking at, sub-millimeter pixel resolution on that.
I think the last question here asking about concerns about using DJI, is the USGS seeking maybe alternatives?
Yeah, that's a big deal. And that is partially why we ended up being grounded, was specifically for not only DJI, but a lot of the other aircraft, even though that the companies like 3DR were based in the United States, and Birdseye, which no longer is operating as a company, components of their aircraft had Chinese component parts. And so there are definitely concerns with that. As we look at our 4th generation of aircraft, we are involved and are on the flight evaluation team for the Department of Defense Blue UAS program. It's not always, apples to apples when we're working with the DoD and what their mission sets are, but we are looking for an escape route into to newer aircraft that we're not as restricted as we are now with the DJI platforms. And I see a question. I'm not sure if Diana dropped off, but
I'm still here.
Oh, you're still here. I see a question on density altitude. So at Kilauea, there was no issue with density altitude. However, we're flying in Colorado, and some of our platforms do very well up to 14,000 feet density altitude, and we fly regularly at 10 plus thousand density altitude. We have to be very wary of that. Some of the military systems we've used in the past, like the RQ-16 T-Hawk, was very susceptible to density altitude issues. So those things that you check for as a manned aircraft pilot, we're checking the same things. We're using different tools. We may be, pulling up the local AWOS or ASOS from an airport to get the local weather, or, working with the National Weather Service on some of our spot forecasting for wildfire, and even our remote automated weather stations to get weather information. But trying to find good information for surface wind flows is very difficult. We found that there's an application that sailors use and people that do wind kiting and windsurfing are pretty familiar with. And so we use SailFlow. It's an app that's out there on a website to get modeled, predicted winds at the surface. And that has been extremely useful for us to for basically wind modeling.
All right, well, we are going to, there's going to be a little extra time at the end. I know there'll be more questions and maybe a time just to chat. But for now, Alina, are you on with me? I hope she was a minute ago. And are you all seeing time to plan? Yes or no?
Yep, we're seeing Diana.
Can you hear me? I'm sorry.
Oh, there we go. Everyone, this is Alina George. Alina and I work together in outreach and engagement. And she actually was a co-lead for Drone Safety Awareness Week, which just happened. And so now she's going to tell you a little bit about that and then some ideas for future. Alina.
Yeah, so Drone Safety Awareness Week, this was the 3rd annual event that we've had. It's been going on for the last 3 years, since 2019. And we've had to adjust a couple of things. So the first year, we had a lot of in-person events. It was 2019. Everything was great. The second year was 2020. It was right in the middle of COVID. So we actually moved everything virtual. And this year, 2021, we actually did a hybrid. Some areas were a little bit more open than others. So there was a possibility for live events. So we had both live events and virtual events. There was a lot of great stuff this year. We focused specifically on recreational flyers. And with recreational flyers, we had a couple of different themes every day, or rather, there was a different theme every day for the whole week, including the weekend. The Monday was take trust. And so for those of you who don't know, trust is the UAS recreational test, safety test that everybody who's flying recreationally does need to take. It is free. We have, I believe it is 18 test administrators. You can find all of that on our website. The second day was register your drone. So we were talking about registrations and markings. Third day was join a flying community. So encouraging people to get involved in drone communities in their areas. Thursday, we talked about the new rules that are coming out. So specifically, we talked about remote ID and operations over people and at night. And then on Friday, we were talking with public safety and talking about public acceptance. I'm going to come back to those two. So hold that in your mind for a moment. And then the weekend was everybody sharing the skies, get out and fly. It was a lot of fun. We also had a couple of new things this year. We did an Instagram Live, which was awesome, with the FAA administrator. So that was a lot of fun. And also I hosted what we're calling Droning On After Dark. And it was an hour every night. It was on YouTube. You can actually go and still watch them. They're on the Pilot Institute's YouTube. We partner with them. They are one of our trust test administrators. And every night we had a different panel exploring the different aspects of recreational drones, specifically looking at FPV. Those are a lot of fun. I highly recommend that you go check them out. Not just because I moderated, but because there was a lot of really interesting information that I didn't know. So a lot of good information there. So next year, this is the big question. And we are coming to you because we would love your help and your thoughts. So next year, we are looking to change the theme. And we would really like to focus on public acceptance and how to reach the folks who either don't know about drones or are afraid of them. You know, this is a new-ish technology, but certainly for a lot of people, they've never heard of drones, or they've heard of drones in the military, and that's scary. So how do we take that fear and actually show people the incredible societal benefits, like you just saw from Lance? There's a lot that we can do with them, and a lot of ways that they are actually helping people day to day right now. So with all of that being said, what we would love to hear from you is a time frame. We were thinking at the FAA having Drone Safety Awareness Week this week in May or June, sometime in summer. What works for you? I know there are a lot of academic folks on here, people who are associated with schools. So we'd love to hear from you. Also, anybody who is with local government, like, is that a busy time for you? Because we want to make sure that we can get your participation. And this year, we're definitely going to be focusing even more on grassroots work. So while Drone Safety Awareness Week is an overarching national event, we would love for local governments, for local police departments, fire departments to be participating and set up some really great live events. So I think that's all I've got. Diana, any questions for me?
No questions, but just to really stress again, we hope to see more community involvement. And then those of you who are within academia, you will probably we'll probably ask this question again at future meetings. And Alina, thank you so much. You did a great effort this year, and next year I know is going to be amazing.
Thank you, Diana. And again, if anybody's got suggestions, we are happy to hear them. We are just starting planning, so we would love to hear all of your thoughts and advice and suggestions. Thank you so much for having me.
I'll put your email in
yes.
the chat and also send it up with the follow-up.
Sounds perfect.
All right, thanks so much. All right, so we are going to move on. I have my notes this time. Sorry about that earlier. Now we're going to change over to what the FAA is doing as far as their environmental programs. I was really fortunate to be included in with a group that are trying to address this. Chris Couture is the AVS Environmental Management Representative and Program Manager, and AVS being Aviation Safety, one of our branches, divisions, I always get those two confused, but for environmental regulatory compliance and sustainability initiatives. I mentioned, to you all in the past, I came from local government. I worked in energy and sustainability. This is very important to me, what they're going to be doing. Prior to that, I actually, and Chris, you may not know this, but I actually taught like the hearing conservation program, so noise, and that's a concern, of course, with anything aviation. So Chris manages the environmental management system and many projects in the environmental reviews for UAS integration. And he's been working at the FAA headquarters since 2014. Previously worked for many federal agencies and corporations on environmental regulatory compliance and sustainability, which I don't know how you all feel about it. To me, though, it's rather exciting. So Chris, thank you for joining us today.
Thank you, Diana. I appreciate the invite. And it's really great to be speaking with such a wonderful community of professionals around the country, and to be following Mr. Brady, USGS. I recognize USGS as the nation's and really the world's premier agency for the earth sciences and biological sciences as well. So it's really great to be sharing your screen. Yes, I'm Chris Couture. I work in the aviation safety line of business at FAA. FAA has a few large lines of business, the Air Traffic Organization, Aviation Safety, which is where we are, the Office of Airports and the Office of Commercial Space Transportation, in addition to a number of other staff offices who work on regulatory and policy issues for the agency. But within AVS, Aviation Safety, there are 8 main services and offices. The Drone Integration Office is just one of those. There's also the Aircraft Certification Service, Office of Rulemaking, Aerospace Medicine, the Flight Standards Service, and a handful of others who perform oversight and really service functions for the National Aerospace System. So today on the next slide, I have an introduction of what I'm going to cover here. So drones, drones have been flying for many years now, and under the Part 107 regulations, the FAA really started to regulate them as aircraft. So there's when that passed in 2016, a whole set of regulations were now applied to these small drones under 55 pounds. So now there's a lot more advanced drone activities taking place. Proponents looking to conduct package deliveries and further beyond visual line of sight for inspections and monitoring and activities like that. So a lot of those activities are not covered under the previous environmental reviews that were done for rulemaking. So we're having to conduct more and more environmental reviews of these more advanced drone integration actions. And so I'll go over that. First, I'm going to go over a little bit of the background of some of the other environmental reviews that the FAA does and how this kind of ties into drones, and then go through our process for what we do look at when we're conducting these environmental impact reviews for specific drone activities, and then some of the other program areas that we're working on now with best practices and developing resources. So I'll go to the next slide. I think this is a background on the National Environmental Policy Act. Most of you have probably heard of NEPA. It's one of the keystone federal environmental statutes. Basically means that federal agencies need to consider the potential environmental impacts to the human environment for actions that they are taking and for actions that require some sort of federal agency funding or authorization or approval, basically meaning the activity cannot take place without some federal agency's authorization or funding or something else approving of a plan or a letter of agreement. We've really, within the FAA, we're the aviation safety line of business, but there's a higher policy office for environmental. I think a couple of our reps from that office are on this call. That's the Office of Environment and Energy. They own a lot of the policy for conducting NEPA reviews, and we follow that. It's FAA Order 1050.1F. And as we'll talk about here, noise is really, especially for traditional crewed aircraft operations, it's really the main environmental impact category that we must focus on. Noise is a pollutant. It's regulated by the Environmental Protection Agency, delegated to the FAA to manage and implement and regulate for aircraft operations. And noise at very significant levels, noise does have health impacts, and it really is an area that's being looked at across the country and across the world. So it's something we take seriously when we're doing our reviews. But there are also other impact categories, on the ground type things that we'll look at as well here. Just a quick overview of some of the activities that that the FAA does NEPA reviews for. Aside from aviation safety, are the other big LOBs, air traffic and airports and commercial space. They conduct many environmental reviews for the traditional crewed operations, especially around airports. So, if you've ever spent time around an airport, there's many takeoffs and landings, and the noise can be concentrated along flight paths. So there's constantly reviewing air traffic procedure changes and altitude changes, and just flight metroplex, flight paths around metropolitan areas. We have teams, actually for airports, we actually do have an anthropologist, archaeologist on staff who helps with ensuring that ground disturbance activities are managed properly and in consultation with state and tribal historic and cultural resource professionals is being conducted properly. And also, I'm sure there are other persons with degrees there that work in the FAA. So there's three main types of environmental review. The CADEX is the basic level, and that's within FAA Order 1050.1F. There are many actions that have been determined over time to not have a significant impact on the environment. So when doing the environmental analysis, if a project can fit under one of those CADEXs, then that is where it goes. And that really shortens up the schedule, although you still need to do a review of the project to make sure that no extraordinary circumstances are triggered. The next level up is the environmental assessment, and those have more formal process requirements to perform, and really a more defined format for what the document needs to include. And so to date, most of our reviews are CADEX and environmental assessments. EISs are really from larger scale infrastructure projects that have been through the initial reviews for a CADEX or EA. They have been determined to have environmental impacts. And so you do the EIS to disclose those impacts and to potentially include mitigation measures that would lessen those. So during the NEPA review process, we also look at, I'm sorry, if we can go back. During the NEPA review process, we also look at a number of other laws. The National Historic Preservation Act, Section 106, just means that we need to consider impacts to historic and cultural resources and conduct outreach as needed. And the Department of Transportation Act, Section 4F, just means that we need to consider impacts to publicly accessible parks, wildlife refuges, historic and cultural sites that could be impacted and potentially impaired by whatever action that the FAA is approving. So here's just a quick overview of kind of what we look at when we're doing these reviews. If whatever the proponent is looking to do, whether it's to conduct package deliveries or long distance and regular infrastructure inspections, then we'll first ask, where is this happening? Are there defined geographical limits? Are there certain properties that they'll only be flying over? and oftentimes we'll ask for a concept of operations or whatever project submittal they're providing to the folks in FAA who are doing the safety analysis. Oftentimes we like to know the proposed number of flights per day and the aircraft type, because that has a big impact on whether the noise impacts could be significant, and whether some of the other environmental impact categories could be triggered for more in-depth analysis. These are the noise, visual, wildlife, cultural, historic. Those are the main areas that we look at. And some of the main questions that we ask are just, would this operation fit within a CADX? And if not, what are some of the further areas of investigation that we need to complete? In this slide here, the first two regulations there that we look at, as part of the NEPA process, those apply only to federal agencies. It's a process that we must complete. But these five wildlife protection laws, those really apply to any operator or landowner in the country. But we also need to look at those when we're doing our NEPA reviews. Next slide. So one of the first processes that we get going once we're able to define a project area or where the operator is looking to conduct operations in the country is cultural and historic resources. Just because a lot of the outreach and consultation for this takes at least 30 days or more, and potentially a lot longer if there's going to be conversations about how to mitigate potential effects to historic or cultural resources. So we get this started as soon as we can hammer out the final details of the proposal. So what we do, there's a number of different resources. The National Register of Historic Places is our go-to place. That's that's only for properties though that are on the register. There's also many other properties that are eligible for listing, and those are managed in state databases. So depending on where the operation is, oftentimes we have to go to the State Historic Preservation Office website, and most states do have geospatial resources that we can use to identify historic districts and historic properties that could be affected. It's really important the type of resource. Most in our National Register properties and eligible properties are listed for architectural or some other aspect that really is not going to be affected by drone overflights. So it's really that small subset of historic properties that have where a quiet setting is an attribute of what makes that property on the National Register of Historic Places or eligible. And the most prominent example I think of is Colonial Williamsburg, but really there's certain experiential type sites all over the country that we need to consider. And the FAA is also doing consultation right now to determine at a national level what types of properties can we just not really consider because they are architectural and drone overflights won't affect them any more than a non-eligible or registered property. And yes, the FAA does do tribal outreach as well for all of our projects that have, even if they're not near tribal reservations in the East Coast or wherever. We use the Tribal Directory Assessment Tool. I can't remember which agent. I think it's HUD that might own TDAT, but anyways, you can put it in the county where the operation is going to take place, and that will pull up any tribes that might have historic cultural interests in that area. And then the program office conducts outreach, sends letters to those tribes, and asks if they have any concerns about the operation moving forward. Since most of these, since all the operations we've been looking at so far do not involve ground disturbance, that takes away a lot of the concerns about archaeological resources being affected, which is a much bigger program area and off of airports where they actually do a lot of ground disturbance. And then once we reach out to them, we'll just make sure that they're not concerned with the actions, and then we close that out and just confirm that there's not going to be any adverse effects. Sorry, Diana, go ahead. One of the main other areas is biological resources. And this is just to make sure that the proposed action in the airspace will not impact special status species, which could be listed under the Endangered Species Act or proposed for listing under Endangered Species Act, or it could just be migratory birds that are covered under the Migratory Bird Treaty Act and the Airborne Hunting Act that you're not allowed to harm unless you get a depredation permit from Fish and Wildlife Service. So what we do, the main tool that we use is the Fish and Wildlife Service's IPAC. And with that tool, which any member of the public can use, it's you can draw the geographical boundaries of where you're going to be operating, and it'll show you which species of concern might be there. And for birds of conservation concern, it shows when they might be listed in the area, the likelihood of them nesting in the area. And it also has other helpful information such as location of wetlands and critical habitat for species that are covered by the Endangered Species Act. And then if we determine that there might actually be an impact to a covered species, we'll do consultation with Fish and Wildlife Service. Oftentimes that just involves calling them up to explain the project and seeing if they have any concerns. And they'll go sometimes talk to their subject matter experts and get their opinions. And then sometimes you have to conduct a more formal letter outreach and get their biological opinions that way. Noise, yes, for aviation projects, usually noise is the most significant. There's a lot of work going on right now with developing new methodologies and ways to model potential drone noise on communities and other noise sensitive areas. The Office of Environment and Energy, they have a whole noise division. And they're currently working with a number of proponents and with Volpe Center up in Massachusetts, who's a part of the Department of Transportation, on really just how do you analyze noise when it's occurring in very low airspace in places where people are not used to having aviation noise, and it could cause issues. So we just want to make sure that we're doing a really thorough review of potential noise impacts on all these NEPA reviews. And it has been challenging just because there's not existing tools or really analysis methods. Noise has analyzed for crewed operations historically using the annual day-night average sound level, where 65 decibels on the annual exposure is really the main threshold of significance. And the lesser amounts of noise that drones emits, you really need a lot of operations to reach 65 dB. So we're just thinking of other metrics or ways to analyze drone noise and consider like the annoyance factor of people who might be exposed to deliveries, or if they live near a nest or takeoff location, how might they be impacted, and should there be any mitigation measures? We also look at visual resources, although there's not a threshold of significance for visual, but we do look at that to make sure that there won't be significant impacts on certain areas. Next slide. 4F resources, this is a big area for drones that we're still looking at. Like what might the potential impacts be of overflight of certain types of publicly accessible areas. We actually use a USGS resource, the Protected Areas Database of the United States, PADIS. And that's the screenshot here on the right, I think is Greensboro as well. Just showing the public parks and state parks and other areas that are protected. we use that to go through an proposed operating area just to make sure that any parts or areas might need further investigation, or just to communicate to the proponent that these are some areas that you should consider limiting your overflights based on the types of activities that could be occurring there at certain times. Next slide. And there are, in our 1050.1F order, there are actually a number of other environmental impact categories. A lot of those have to do with on the ground disturbance. So the ones we've highlighted in this presentation are really the ones we focus on for airspace activities. The air quality. I think most of the drones we've looked at so far are not gas powered, so they actually have environmental benefits in that way, especially if they're replacing helicopter operations. So we're usually able to quickly write off air quality as no impact at all, and if anything, positive impact. There's about 5 different water resource categories: surface waters, ground waters, and things like that. But really, just the wild and scenic rivers impacts is what we look at for drone overflights. There's not certain parts of the country there aren't any wild and scenic river segments. A lot of them are out west, or really in wild places where there's more wildlands. And even if an operation is being proposed by a segment that's covered, that's listed in the Wild and Scenic Rivers Act regulations, we just need to make sure that if there are going to be flights over it, that it won't be at such a frequency or intensity that they could cause a detrimental impact to people who might be using that river segment. And then another area is environmental justice, is just making sure that the proposed action is not going to have a disproportionately high or adverse impact to EJ populations. And we haven't identified that so far, but there are some theoretical ways where that could happen, such as adjusting routes to avoid a public park, but then that could shift the noise over a lower income neighborhood. So it's something we're looking at, and there might be more interest in that in the future. Next slide. Community engagement. There's a lot happening with the drone integration folks, and just in general with community engagement. It's very important for crewed operations when there's procedural changes in cities, and FAA has to send out the community engagement people to hold community meetings and hear people's concerns and just make sure that the process is being followed. It's coming up more and more with drones as people are looking to operate in more densely populated areas, and a small subset of people just do not want drones, at least not yet, flying over their neighborhoods or their property. So we always encourage the proponents to do their own community outreach as much as possible. And for certain environmental reviews, usually just for the EA and environment and the EIS levels, then FAA has to conduct its own community engagement and post documents for public comment period. And it is a formal process. But we can rely as much as possible on the proponents. They're the ones who are, it's their action really, and it's in their interest to engage the public and make sure that concerns are addressed before they reach the level of becoming an issue. And another area, this is kind of beyond NEPA reviews and beyond our regulatory requirements, is right now the FAA is looking at developing best practices. We're pulling a lot of best practices that the resource management agencies like USGS and Forest Service and NOAA and the National Park Service have developed. And it's pretty just basic, common sense information. If you're planning flights over, if you're planning regular, prolonged, repetitive flights over noise-sensitive areas, consider the potential impacts to humans and other creatures on the ground that might be disturbed. Conduct outreach as needed. Look at the areas where you're flying over and just realize that there could be noise-sensitive resources on the ground, and just planning your overflights that way. And an area that's coming up more and more is bird nesting areas and other kind of critical habitat for bird and other wildlife feeding and their critical life cycles. And we're just telling people to follow those state, local, federal regulations. If you see a no drone zone, then don't fly. And if it's an area where birds are nesting, to just do not fly there. And for marine mammals, there actually are regulations owned by NOAA for operating a certain distance away from marine mammals. And with this, we actually are seeking input from, so if anyone has suggestions for where best practices would be most helpful, or certain resources that might need updates, like we're looking, I don't know how many of you use the Before You Fly app, but we're looking right now at updating that with some best practices and really seeing where we'll be able to reach the largest number of people, whether through the FAA website or Before You Fly or social media or somewhere else, is just to get the word out that these are the things you need to consider to do your part and make sure that the environment is being protected and that you're covering your own due diligence so you won't get in trouble yourself with these environmental protection laws. And so I'm just providing some resources here. It's links to some of our key resources, and we can provide other resources as well to some of the tools like IPAC, if that would be helpful. But just wanted to add this slide. And, feel free to reach out anytime with questions, and thank you very much for your time. Back to you, Diana.
I was hurrying back to click. It wasn't going as fast as I was trying to get it to. Chris, thank you so much. And I'm going to post your email. I'm going to post the links that you just had in there. And Lance, I don't have yours right up, just right at this moment. If you don't mind to post yours in there as well. And we are just delighted that you have been here today. Let's just open it up now. Any of you that have questions, turn your cameras on, unmute yourself, and you are welcome to ask any questions. Alina's still on. I see a lot of you here today that may even have questions for each other, so please feel free to do that.
Hey, this is Basil with NCDAT. Got a quick question.
Yeah, Basil, go right ahead. So glad you're here today.
So Chris, the Part 107 rules were all a Cat X. We have the ops at night and ops over people, which I assume were a Cat X as well when those got released. So this, I guess, kind of your overview of the application of NEPA is really for any new FA or new operations. My assumption is under 135 or under new waivers. Is that right?
Yes, in general, if it's an action that is beyond the scope allowed by 107 or ops over people, then we're looking to document NEPA reviews for those.
Okay. And then I know you mentioned noise a couple of times, and obviously noise is something we often think of with UAS. And I guess so we just have the volume of noise, but you introduced something else there around the annoyance of their sound. Is that something, the annoyance or frequency, is that something you guys have historically looked at, or has it just been sound?
Noise annoyance has been looked at. Not having a threshold of significance makes it difficult. So it really becomes more subjective, and you can use certain number of noise complaints and things like that. I don't work in air traffic or airports, so I'm not sure exactly how noise annoyance has been incorporated into NEPA reviews in the past, just because it is so subjective. And with around airports, you can really use the noise metrics much easier. So I think that's really being more developed as noise annoyance, and we're careful to not delve too far into that right now, because one person's annoyance might be another person's. It's something happening out there during the day, and that can be inevitable sometimes with yard work and truck deliveries and things like that. So in general, we haven't gone too far down that path. It's something that we're open to taking suggestions on. But yeah, that's a good question. Okay, so it's how do you consider noise annoyance? And
I know they certainly have a higher frequency, and we've seen studies in animals that they're closer than frequency of bees, which is bothersome for sure. But I had just not seen or heard that before as something that was introduced as something you'd be looking at in NEPA review. So that's helpful.
This is Shauna. I work for the office that Chris referenced, the Office of Environment and Energy, that has the noise division. And while I am not the noise expert, I can just sort of clarify that, in doing our NEPA reviews, we are evaluating the noise consistent with previous methods, and that our major point of comparison is our established noise threshold in FAA Order 1050.1F. And of course, in the sort of qualitative discussions of our NEPA reviews, we do want to be able to properly contextualize how this noise might be different than what people are used to experiencing. But our primary source of comparison is those established thresholds.
Wait, is there a reference in other modes of transportation that you can use around annoyance? Or are you guys just kind of going from scratch there?
Go ahead, Ann.
I mean, I don't know that I have much to say on that, but I would say that FAA is developing the methodologies that it needs to assess noise impacts, and we're using existing methodologies that we have. So I know, I mean, maybe Chris was thinking of the larger noise study that was put out for comment earlier this year. We did have a larger study that went out, and Shauna can probably speak to it a little more than I can, but we had done a larger noise study to assess how just generally noise from aircraft, not just UA, but aircraft, how annoyed people are by that noise. And I know we put out that report for comment, and I think that comment period is closed, and we're probably assessing the comments and responding to those comments. So this is certainly annoyance from aircraft is not isolated to unmanned aircraft actions, and it is something that in general FAA is assessing. I mean, Shauna, is that a fair characterization?
I think that was perfect, Ann, and I'm actually pasting our website that discusses the neighborhood environmental survey that we conducted. That includes the methodology and the results thus far that are published about our more recent research into aviation noise.
Thank you.
Other questions? Yeah, I find that all very interesting on the noise. I wonder if have any of our schools, maybe through the Assure program, test sites, have they been like using instrumentation for the different types of UAS sound levels and such? Has a report like that been done, or research?
I could tell you as a manufacturer, I've measured UAS noise as a normal part of the job to determine sound levels. But I can't say operators do know how to do that.
Yeah, and your question about FAA coordinating with OSHA on noise, I'm assuming what the decibel level you were saying earlier sounds pretty common to OSHA.
Yeah, the two concerns previously are the sound levels in excess of the permissible exposures, and then the second one is interfering with safety critical communications.
Right. All right. Do we have any more questions? I think Lance is still on as well. If we want to go back and have any more questions for Lance. Yeah, I see you, Lance.
I'm still here.
All right. Well, Thank you all again. It's a few minutes past 4:30, so I hope you have a great evening. And for those of you that have the federal holiday on Monday, that you have a great long weekend. And we will see you at the next Connected by Drones.
Thank you, Diana.
Thank you.
Thank you all.